Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Riz Hakim bin Muhammad Fardusi. My number metric is DE220118. So today I'm going to present my simulation, and I'm doing the activity 1, this is the circuit that I will be simulating. Okay, so there is inductor, there is resistor, there is voltage source, ammeter, and these two are the voltmeter, and in the middle there is power meter. So I have to do is I have to alter the value of the Vs, that is voltage source. Okay, so this is the circuit given, and this is the circuit that I simulate. I turn the circuit into the simulation. So this is the value for the, this is for the power meter. Here is the power meter. So this is the value for the ammeter. This is the ammeter. This two is the voltmeter. This voltmeter for this, and this is the value for the voltmeter. This. Alright. So I already put the resistor, inductor, all the needed things here. Ground. Okay. So this is the value for the 10 Vs. Alright. So I have put in my table. So it is the same. Okay. For the 20 volt, just tap the voltage source and just alter the value in this voltage RMS. Okay, so when you want to change the value, you have to stop the simulation first, and then you run it again. Okay, then you just wait a few minutes. Okay, then you stop again. Alright, this is the value for the 20 Vs. Okay, so here the 20 Vs, it is the same with the value I got in the simulation. Alright, then we change again the value 30 Vs. Okay, and then we play it again and run it again, and then we just wait a few seconds. Okay, then you can stop. So this is the value for the 30 Vs. Here the value. Alright, same goes to 40 Vs. Just run it again, and then we can stop it. Okay, so it's the value 39.483 watt. Just the same value in this. Alright, so we have to change it again to 50 Vs. Then we have to run it again. Okay, so here are the value for the 50 Vs. It's the same with the table. I already put in table, and then we have to alter the value into 60 Vs, 60 volt. We have to run it again. Just wait a few seconds and stop it. This is the value for the power meter, for the ammeter, for the voltmeter. Okay, so this is the value, just the same value. And then for 70 volt, just run it again, then wait a few seconds, then we can stop. Okay, so this is the value of power meter, ammeter, same with the table. Okay, and then 80 Vs. Run it again, stop, and then this is the value for the 80 volt. And then 90 volt, we have to alter the value 90 volt. So this is the value for 90 volt, just the same value with this table. Okay, for the last one is 100 volt. Run it again, wait a few seconds. Okay, so this is the final value for the 100 volt. Alright, this is the value. Okay, that's all from me.
Assalamualaikum warahmatullahi wabarakatuh, and good morning. My name is Nik Muhammad Amiruddin bin Azran, and my metric number is DE220179. Okay, today I will present my works, which is step for the table 4.2. Okay, for this exercise activity, we just change the resistance from 30 ohm to 100 ohm. Okay, and then this simulation, we just need to change the voltage number from 10 volt to 100 volt. Okay. Firstly, we change to the 10 volt. Okay. This is the result until, and then we just only change the voltage number, and then we will get all the result we need. Just like this, I make in the this for this result I made in the table. I fill in the blank in the table for 4.2. Okay. This is the result. This is the example from my multi-sim. We got VS 10 volt, VS 20 volt, VS 30 volt until VS 100 volt. Okay.
Hi, Assalamualaikum. My name is Muhammad Zahra Amsyar, and my matrix number is CE220086. So today I will explain about the experiment 4, which is I have to conduct experiment 4, activity 2, part A. So the circuit diagram that given is here on the left sheet, and this is the circuit diagram that I do on Portal software, which is I need to use a capacitor, resistor, and V sign. So first we have to set the V sign value, resistance, and capacitor value. For the V sign, we have to put the value 10 volt, but we have to multiply by 1.414 because this is the V sign, but we need to raise it into a VRMS. So that's why we have to multiply by 1.414. So then we're running. And this is the value for 10 is 0.06 ampere. For the VR 6.55, VC 7.56, and power is 0.66. Next 20 volt multiplied by. So for the 20 volt ampere is 0.13, VR 13.1, VC 50.1, and power is 2.64. Next is 30. Then running for the ampere 0.2 ampere, VR 19.7, VC 22.7, and the last one power is 5.94. Next 40 multiplied by 1.414. Then running for 40 ampere is 0.26 ampere, VR is 26.2, VC 30.3, and power 0.6. Next is 50. From 50, 0.33, VR 32.8, VC is 37.8, and the last one power is 60.5. Next is 60. For 16, the NP is 0.39, the VR is 39.3, VC 45.4, and this one is power 22.7. Next, change to 70. For 70 is 0.46, VR 55.9, VC is 52.9, and the last one power is 32.3. Next is 18. For 18 is ampere 0.52, VR is 52.4, VC 16.5, and power 42.2. Next is 19. And the ampere is 0.59, VR is 59, VC is 68.1, and the last one power 53.4. And the last one is 100 volt. Timing for the ampere is 0.66, VR is 65.5, DC 75.6, and the last one is 65.9 watt. So that's it for the part A activity 2 for the measurement result.
Assalamualaikum and hi, my name is Muhammad Syamil Aiman bin Muhammad Sabri and my number metric is DE220127. Today I will explain how I do my circuit and explain how I get the value from the table 4.4. Okay, first of all, I do it table 4.4, measurement result for resistance 50 ohm and capacitance 28 microfarad. So for the first example is VS 100 volt. So first I copy the circuit from this from the assignment, just like that, and then I replace it to the multisim online. So the value I get it is 100 volt and 50 ohm, and the total for the capacitance is 28 microfarad. So the value from the last capacitance is, I put in the voltage voltmeter, and before the resistance is voltmeter also, and the power meter, and after sources is ammeter. So after that I just play it, and then this is the value that I get it, and then I just put it to the table. So the next step is just the same step for the previous step. So I continue to the until I done for all the result. So I just put it into the table. Okay, so that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shazwan. So today I will present about the conclusion of the series RL and RC circuit. Okay, the first point is within this experiment we can find the impedance, power and power factor of the circuit in the steady state response of RC and RL circuit. Okay, and the second one is in we doing this simulation in this lab 4, we got to learn about the variously consuming, storing or supplying electrical energy, and they are the types of elements respond to electrical voltage in different ways. And as we can see, this is two types of the steady state behavior in series circuit of RC and RL. And that's it for the conclusion in this lab. That's all for me. Thank you.